In almost any scientific endeavor, you want to be able to try to interrogate the system that you're trying to understand. You poke it and prod it some way and you try to understand how it's going to respond.
In the Renew Robotics Lab, we are interested in applying engineering principles to improve people's lives. Specifically, we build robots that connect to the human body, and those would be used for rehabilitation and assistive applications. We are motivated by understanding how the humans move, and we conduct experiments on the human subjects to understand precisely how the body moves and how the body controls its own limbs. And we take that knowledge and use that knowledge to build our robots. For example, we are studying human hands very closely. We are understanding the hand biomechanics and hand control, and using that knowledge to build an advanced hand prosthesis. In the future, I anticipate robots being fully integrated in the therapy setting, where they're taking some of the difficult load from the therapist and implementing therapy more precisely.
So what we have here is a system where with the treadmill, we can apply mechanical perturbations to the treadmill, and we can essentially prod people mechanically while they're walking. We can actually change the speeds of the treadmill belt, and we can kind of prod their somatosensory information, the sensory information they get from their feet and their legs while they're walking. We can perturb the visual information through the virtual reality stuff and do visual perturbations. So the equipment can be used both as a diagnostic tool, so we can determine by providing different combinations of different perturbations, we should be able to determine whether or not a person's impairment is primarily physical or biomechanical. Is it a strength issue? Or is it sensory? They're just not sensing the perturbations. Or is it more of a cognitive issue? Ultimately, we'd like to be able to see if we can take the specific things that we learn from this system and build that into a take-home type of a system that would be a small treadmill with a Wii and a television, and the therapist and the clinician can monitor everything that the patient is doing at home.
We are interested in human-centered robotics. Human-centered robotics is those robots that operate right next to the human or augment the human. We're interested in issues such as the control systems. We're interested in the design of those devices, what is the electronics, the mechatronics, and the actuators that they contain. And we're interested in the software that runs on this system and how can it be used. With NASA, we are making technologies where we can go to can support the missions in other planets by building instrumentation and cooperating with the astronauts. With the Navy, we are making, designing robots that can go inside vessels and put out fires. Finally, with the Defense Department, we are exploring the idea of having robots that can go inside nuclear power plants and can shut them down in case that there is a disaster scenario. In 5-10 years, we're going to see a lot more robots operating right next to the human and being at the same time 100% safe.
In the Rewire Lab, what we do is we take neuroscientific knowledge and we combine it with engineering concepts to develop better, smarter methods of stroke rehabilitation. One of the tools we're developing right now is a form of biofeedback. We call it neurofeedback. The way it works is we measure brain activity in an MRI scanner, and we take the activity in specific brain regions that we think are important for recovery, and then we make the patient aware of that activity. And that way they have the ability to control it. The exciting part about being able to measure what people are doing in the scanner environment is that we can guide what they're doing using their own brain activity. So it forms a special kind of neurally guided, targeted physical therapy that can be customized to each patient. So in the future, we can go to the MRI scanner, learn to control these brain circuits, and then when we go home and perform our physical therapy, we can reinforce those brain circuits that we know are targeted specific to the malady. Here at the University of Texas, we have the unique ability to develop robotic and engineering tools to understand the neural and biomechanical causes of an impairment. This is going to open up a whole new range of exciting clinical options in the future.